All right, welcome to Simplifying Radicals, Math B. Today we're going to take a look at reducing numbers, being able to find the square roots of numbers. So what you see in front of you, this symbol, is called a radical. The example in front of you is a square root. It is one of the types of radicals. We have things like the cube root, the fourth root, the fifth root, so on until 100th root, 1000th root. So we call that symbol a radical, and then we discuss the different types of radicals based on whatever root they are. And in this example, in this lesson, we're just going to talk about square roots. So in order to understand how to simplify square roots, we first need to understand what a perfect square is. So a perfect square is the same number times itself. So for example, 1 squared is 1. 2 squared is 4, because it's 2 times 2. 3 squared is 9. Oops, forgot that little squared part. 4 squared is 16. 5 squared is 25. If you notice your pattern, the next one is going to be 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We skip 19, we get 20, and I believe 25. We'll use these when simplifying. Ooh, excuse me. We'll use these when we go to simplify expressions that are not perfect. So let's first take a look at the square root of perfect numbers. Well, the square root of 4 is 2. If I go back to the chart, 4 is on that chart. To undo that, it's the same thing as saying the square root of 2 squared, because you agree with me that 2 squared is 4. Well, my square root and my squared term cancel out, so I'm just left with whatever's left. Same thing with 16. Same thing as 4 squared, so the square root of 4 squared. My square root and my squared term cancel out, so my answer is just 4. Alright, sorry guys, you probably noticed I just paused the video for a second. My allergies are getting the best of me this afternoon, so I apologize if I keep having to pause. It's because I need to blow my nose, and quite frankly, I don't think anyone wants to listen to that. So, we just left off with my square root of 16 being 4. So again, 5 squared, the square root of that, they all cancel. I'm only left with 5. Once I take the square root of a number, so say I take the square root of 81, I'm doing an actual operation here. So the square root of 81 is simply 9, because 9 times 9 gives me 81. Now notice that square root sign has disappeared because it's an operation. I've done it. It's like saying 4 plus 2. That gives me 6. I don't then try and add 6 with something else because of the fact that there's nothing else to add with it. I've already done what's been asked of me. So same idea. Even though you're correct, 9 is another perfect square, I could take the square root of 9 because that is 3. However, I'm only taking the square root of whatever has a square root symbol with it. I have done that operation, so therefore I do not add it with my 9, and my answer is simply just 9. Okay, we're going to look at simplifying some numbers that are not necessarily perfect. Oops, not meaning to move that. Got some coffee on my screen. Alright, so let's take a look at the square root of 8. If I go back for a second, bear with me please, I see that 8 is not on that perfect square list. You're like, man, but it totally fit right between 9 and 4. But no number squared will give me 8 evenly. That being said, we're going to have to use my perfect squares to help me figure out what multiplies into 8. Now, I'm going to show these next few examples a couple different ways. The first way I'm going to talk about is when I have two numbers being multiplied together, one perfect and one perfect. So if I go back to that list for a moment, I want to see what of my perfect square numbers, my typed numbers on here, multiply together to give me 8. Now, I'm not looking for the same number twice. I'm looking for one perfect number times another number. Well, you're probably thinking 4 times something gives me 8. Well, 4 times 2. So 4 is perfect, but 2 is not. So 4 times 2 gives me that 8. Okay, the square root of 4 is 2 because it is perfect. Next, I try and take the square root of that 2 that's still underneath it. Well, 2 is not a perfect square. It's not on that chart. It's not on that list of typed numbers, excuse me. So because it is not perfect, it stays underneath and it cannot come outside and hang out. That is my simplified answer. We'll do one more example like that. So I'm going to go back for a second and look at what multiplies into 20. One of those numbers will be on the list again. So same idea with the green arrows. One number will not. So some people are probably thinking 10 and 2. Well, neither 10 nor 2 are on that list. So I want to find another number, or another pair of numbers, excuse me, that multiplies to give me that 20. Did you come up with 4 and 5? So the square root of 20 is equal to the square root of 4 times 5. The square root of 4 is 2. 5 is not a perfect square, so he's just going to hang out underneath. That's my answer. Now I want to approach this a slightly different way for this next example. Not wrong, not any easier, not any harder, just different. So what if I'm really bad at math and I don't understand and I can't see easy numbers that are on that perfect squared list that multiply into each number? Then what do? I need another strategy, right? Because shoot, I'm not going to know what 81 multiplies into. Like, that's ridiculous. How do you expect me to know that? Well, I don't anticipate you to know every single one. So yes, granted 32 is a little bit smaller, you might be able to see what it goes into. So what I'm going to do is called the factor tree. I'm going to come up with numbers that multiply into 32. Well, I know that 2 multiplies into 32. 2 times 16. The whole idea of making my factor tree is to try and get to the smallest number possible. Numbers that only can be, you can only get those numbers by multiplying that number by 1. So for example, I have 2 and 16. 2 can only be multiplied by 2 times 1. That's the only way you can get to 2. But 16, you can have multiple things multiplying to 16, right? I can have 2 and 8. I can have 4 and 4. Either one. Let's go with the 2 and the 8. I'm trying to keep a pattern here. Again, 2 is what's called prime. That's what I'm looking for. Prime means it's only that number times 1. Itself and 1. 2 is a prime number. That's the only way you can get to 2. 2 times 1, that's the only way. 8, however, can be multiplied by 2 times 4. And 4 is equal to 2 times 2. You're probably thinking, well, what the heck? I don't understand what we're doing. This seems harder. The other way had less steps. What's going on, Miss Kimmy? You're freaking me out. The whole idea here is to find, then, groups of the smallest number. I want groups of 2 because I'm dealing with square roots. When we start looking at more complex roots, we will look at more pairs of numbers or multiple pairs of those numbers. So because I'm dealing with squares, square is 2, I want 2. So I have one group of 2, I have another group of 2, and then I have a 2 left over. So for every group that I circled, one factor of those 2 gets to come out. So I got 1, 2 from this one. Then I get another 2 from the second one. And they're going to come outside and hang out because I had a pair. My buddy wants to come out. Whenever I pull something out of my square root, those numbers become multiplied. Just like every number underneath is multiplied, whenever you pull something out, it's still being multiplied. Can't forget my little 2 that was left under there. So now I'm going to simplify that one more step. And I get 4 root 2. Oops. Sorry. My menu's on that side. Let's try this with the 75. Now 75, think to yourself, well, what the heck, Miss Kimmy? 75 is not divisible by 2, is it? Nope. What about 3? Nope. 4, well, 4 is not prime, so we don't really want to try that. What about 5? Does 5 go into 75? Yep. 5 times 15 gives me 75. Now remember, we were talking about prime numbers being numbers that only multiply themselves in 1. So 5 times 1 is the only way I can get 5. So it's prime. I'm going to leave it alone. Let's break up this 15. 15 is equal to 5 times 3. Well, 5 can't be broken down, and neither can 3. But if you notice, I have a pair of 5s, don't I? I got 2 of them. So that means that I can take out one of them and then leave that square root of 3, or excuse me, leave that 3 underneath the square root sign. Now we talked about 2 different ways in this first slide. I want you to pick one of those ways. I want you to pause this video, and I want you to try the square root of 40. Paused yet? Okay. Square root of 40 is 2 root 10. Now, if you didn't try that one, and you just kept on going with the video, you don't have any way to figure out. So go back and try it on your own. Alright, so we have some more examples here to try. 48, 80, 50, 125, and 450. So I'm going to try and do both ways as much as I can. I think I'm going to split it just like I did the slide before. If you prefer one way versus the other, so say I do looking for the perfect squares times an unperfect square, and I'm using the factor tree, then go ahead and do it your way and make sure that at the end we all agree on the same answer. So again, I'm trying this 2 different ways. I want you to figure out what is the best way for you to understand it, and then make sure you use that way every time. So this first one, I'm going to look at my perfect squares. So I'm going to think of the 2 numbers that multiply together to give me 48, one of them being on that perfect squares number, or perfect squares list. So I'm going to go back, and I'm going to look for one of the numbers in black that divides into 48. Now you're probably thinking, well, hey, 48 divided by 4 gives me 12. But why don't you try 16? Does 16 go into 48? Yeah, it goes in 3 times, right? Well, why don't we want to use 4? Well, if we look at the square root of 12 for a second, this is what's called an aside. The square root of 12 breaks into the square root of 4 times the square root of 3. Square root of 4 is 2. Square root of 3 doesn't change. So I know I'm going to end up having to try and do that again if I use 4 and 12. I don't want to do that. I'm going to try and pick the biggest possible perfect square. So if I use 16 and 3, oops, I thought I changed that, my bad. I know that 3 cannot be broken down. I want to do the smallest possible prime number to multiply that square term with, or that perfect square with. So next I'm going to take the square root of my perfect square, which is 4. We already said the square root of 3 can't be broken down. That's my answer. For 80, I'm going to do the tree. Now, I don't have to divide by 2 every single time. In this case, I'm going to divide by 4 and 20 because I want to show you something cool. Because sometimes we think of other stuff that goes into it. We could do 10 and 8, 4 and 20, 2 and 40. As long as we end up making sure we get simplified as much as possible. So 4 is equal to 2 times 2. 20 is equal to 4 times 5. 4 gives me 2 times 2, and 5 can't reduce down any farther. One group of 2, 2 groups of 2, and one lonely 5. So I'm going to have 2 times 2, square root of 5. 2 times 2 is 4. My square root of 5 follows with. Alright, I'm starting to run out of room because we all know I write super large. So I'm just going to change colors. So the next one we're doing is square root of 50. Should still be the same as yours. I'm just moving it down because I ran out of room. So let's think of 2 numbers that multiply to 50. One of them being perfect and one of them being imperfect or being prime. So let's go look at our chart. What multiplies into 50? Well, when I see 50, I try and think to myself quarters, right? Because guess what? A quarter, or 25, is perfect. So I know that 2 quarters gives me 50 cents. So 25 times 2 is how I get to 50. 25 is perfect. The square root of 25 is 5. That square root of 2 just follows with. All right, next example, 125. All right, well, let's see what multiplies into 125. 2 doesn't work. 3 doesn't work. Well, let's take a look at 5. 5 times what gives me 125? 25. 5 can't be broken down. 25 is 5 times 5. Hey, look, I got my group of 5. So I have 1 5 come out, 1 5 hang underneath. My answer is 5 root 25. Last one, I want you to do 450, one of the 2 methods on your own. Remember, pause it. We'll take a look at it here in a second. We will talk about the answer together. All right, sorry about that long pause. I ended up having to pause the video because my mom decided she needed to call me. So again, I'm sorry about that. So we're taking a look at the square root of 450. Do we all agree that we end up getting 15 root 2? Excellent. So here's a little quick review. Again, there's 2 different ways. One way is to multiply the perfect square times the factor, and then you take the square of the perfect square, that's the answer, times that other factor. Or you can do the factor tree. Which is the way of finding the smallest numbers to multiply in. All right, hope this video helps. Maybe I'll see you tomorrow.